All right, welcome to Chemistry 101. Let's go ahead and just start off with some tips for success. In this class and in many other classes as well, and just life in general. So the number one tip I have for you is use your resources. Right, you're not the first person to learn chemistry. There's plenty of resources out there for you, and then there's plenty of people around you who want to help you, right? So one resource, and the first resource you probably have is me or your professor if you're taking some other class. And generally the way that you interact with professors, email is okay, but if you want to discuss more complex topics, I'd suggest coming to office hours. For those of you that are new to college, office hours are just basically times where instructors make themselves available for any type of questions you have, or whether you just want to chat about something else. I'll post my office hours. It depends on availability, but so those will be to be determined. Some other resources in terms of just this class, you're going to have a lot of work along, which are basically just problem sets that go along with your lecture videos. You definitely want to use those, and of course any extra practice problems that I post as well. I'll post some of them depending on the difficulty of the content. Early in the first few weeks you won't see a lot of them. Later on, as the content gets a little bit more difficult, there'll be extra practice problems and more intense work-alongs. Of course, it's the 21st century. You have the internet. I'm a big fan of the internet. I don't think there's anything wrong with using the internet as a resource. There's of course a word of caution, and you do want to be careful there. As great as the internet is and has how many cool things it has a lot of wrong stuff on there too. So if you're using the internet and you think you're not sure of something, stop by and I can let you know, right? I'm here to help. So if you're using some kind of resource and it doesn't seem to be benefiting you, or if you think that they just have something that's wrong, let me know and we can discuss. And then finally, another very important resource will be Tutors. MSJC offers tutors for all of our course content. I know a couple of tutors, I recommended them for tutoring. They're really good. So similar to my office hours, you can drop in and ask them questions. And sometimes, hearing it from somebody else just works a little bit better. These will be to be determined. Usually the tutoring schedule comes along the second or third or fourth week of the semester. As soon as those are available, I'll go ahead and post them to Canvas so you'll know them. So that's tip number one, is use your resources. Tip number two is to pace yourself. Right, so imagine you're training for a marathon, right? What you would do is you train one day, you'd rest a little bit, then you train again, then you'd rest a little bit, then you train again, right? You wouldn't imagine that, tomorrow, if you didn't run at all, that tomorrow you could run a marathon. And the same thing happens for studying. A lot of students think that they can just cram the night before. And while that, may work depending on the difficulty of the course and whatnot, it doesn't foster long-term learning. And in general, it's just not a good idea. So pace yourself, do a little bit of studying, rest a little bit, do a little bit more studying, rest a little bit. At first, that might seem more tedious than cramming, but in the long run, it'll actually save you a lot of time. Because again, cramming doesn't lead to long-term memory. And so you'll learn something, you'll cram it, and then, a couple weeks later, you're going to forget it. And when you take the next exam or you take the next course in the sequence, you're just going to have to relearn it. Tip number three is active learning. Again, similar to, maybe training for a marathon, you wouldn't just watch somebody run a marathon and think that that would help you very much to, run a marathon. However, nowadays, a lot of students like to just watch YouTube videos of people solving problems. And so while watching a video isn't a bad thing, and it's actually good for the intro, the introduction into a topic, it's not actually that great for learning. Similar to how if you want to be a good runner, you need to go out there and run. If you want to do well in chemistry or any other, academic subject, you need to do that academic subject, right? So you must do. And so this usually involves doing some types of practice problems, or labs or activities or anything like that, right? But really getting in there and interacting with the course content is the best way to learn. Number 4 is more of a chemistry/science type of thing. So when we think about science, a lot of people think that science is black and white. Either something's wrong or something's right. And that's just not very true. In science, there are generally no absolutes, right? We don't have something that this is always true or that is always true. We have more so guidelines that work under certain conditions. So for example, right, if you throw something up in the air, it must come down, right? So a common saying is what goes up must come down. And that in general is true, right? If you throw a ball in the air, it'll come down. If you kick a ball in the air, it'll come down. Anything you throw up will come down. But that's not always true. If you're in space, that's not true. If you throw something in space, it's going to go on almost forever, right? So always be careful of statements that people make because they're making them assuming some conditions, right? So you need to be aware of those conditions and understand the limitations of any statements. So along with this goes with be careful of categories. In general, we like to categorize things. Things are either plants or animals, right? But that's not really how the real world works. There's a lot of things that can't be categorized. So let's say you have 3 categories, A, B, C, or in chemistry later on, we'll learn about gases, liquids, and solids. Well, anytime that you have a category, there's always going to be something that doesn't fit in one of those categories. So for example, what about a gel? Is a gel a liquid or is it a solid, right? It's not really either of them. So in general, be careful of categories, be careful of absolutes. Everything that we say has some sort of context and you need to be aware of that context. And number 5, the way that kind of science and learning in general is organized is that we start with simple models that are generally less accurate, and we build up to more accurate models. But these models are often more complex, right? And so a lot of times people want to skip straight to the most complex, right? Because that one's generally the more correct model. But making that leap is often just too difficult, right? We need to do some sort of scaffolding. We need to start you off with something a little bit simpler that works in most cases, but isn't totally true, and then build up to, closer and closer to the real reality of things. So an example of this is language, right? When you were little, you learned the alphabet. Hopefully you still know it, right? A, B, C, D, so on and so forth, right? And if you think about the alphabet, there's 26 letters. Actually didn't double check that, so hopefully I'm right. And then you look at a little kid learning, right? 26 letters. That means that there should be 26 sounds, and they should be able to spell out anything, and then basically, say the sounds of the letters and pronounce the word. Does that work? No. No, it does not, right? There are way more than 26 sounds, and letters often have multiple sounds depending on their context, right? But we don't tell that to little kids right away. We don't expect them to jump and know every single sound that's possible, every single combination of the words. We start them off with the alphabet, and then we introduce, more complex systems, more accurate systems as we go on. So just because the alphabet isn't 100% accurate, it's still useful. And so that's what we'll be doing a lot in this class. We'll be introducing relatively simple models that model the way that the universe or that the world works. And they're not going to be accurate in every single case. However, they're going to be a great starting point to learn about the more complex situations. Again, this kind of goes back to the no absolutes thing, is that we need to know the context of everything. So overall, I'm using these 5 tips for success, especially I would say the first 3, right? Really using your resources, pacing yourself, and active learning. that should set you up for success, not just in this class, but any endeavor in your life. So cool. Good luck.